Start with the basics. What exactly is a microcontroller? Imagine a tiny computer, small enough to fit on your fingertip yet powerful enough to control everything from your microwave to your car's engine. A microcontroller is an integrated circuit that contains a processor, memory, and input-output peripherals all on a single chip. Unlike a regular computer, it's designed to perform specific tasks, often in real time. This makes microcontrollers the brains behind countless everyday devices, quietly working in the background to make our lives easier and more efficient. Microcontrollers have a fascinating history that dates back to the early 1970s. The first commercially available microcontroller was the TMS-1000, developed by Texas Instruments in 1974. This innovation revolutionized electronics by making it possible to embed intelligence into small, affordable devices. Over the decades, microcontrollers have become more powerful, energy efficient, and cost-effective. Today, they are a fundamental building block in modern electronics, enabling everything from smart home gadgets to advanced industrial automation. Every microcontroller is made up of three main components: the central processing unit, CPU, memory, and input-output I/O ports. The CPU acts as the brain, executing instructions and making decisions. Memory stores data and program code, while I/O ports allow the microcontroller to communicate with the outside world. These components are all packed into a single chip, making microcontrollers compact and efficient. This integration is what allows them to be embedded in such a wide variety of devices. Microcontrollers operate by running a program stored in their memory. This program tells the microcontroller how to respond to inputs, such as pressing a button or receiving a sensor signal. The microcontroller processes this information and then controls outputs, like turning on a light or activating a motor. This cycle of reading inputs, processing data, and controlling outputs happens incredibly fast, often thousands or millions of times per second, enabling real-time control in electronic systems. It's easy to confuse microcontrollers with microprocessors, but they serve different purposes. A microprocessor is the central unit of a computer system, requiring external components like memory and input-output devices to function. In contrast, a microcontroller combines all these elements into one chip, making it ideal for dedicated tasks in embedded systems. This distinction is why microcontrollers are found in appliances, toys, and vehicles, while microprocessors power personal computers and servers. Microcontrollers are everywhere. They're used in household appliances like washing machines, microwaves, and refrigerators. You'll also find them in cars, controlling everything from engine timing to airbag deployment. In the medical field, microcontrollers power devices such as blood pressure monitors and insulin pumps. Even toys and remote controls rely on these tiny chips to function. Their versatility and reliability make them indispensable in modern life. Smart homes are a great example of microcontrollers at work. From thermostats that learn your preferences to security systems that keep your home safe, microcontrollers are the silent operators behind the scenes. They process data from sensors, control lighting and climate, and even manage your entertainment systems. Thanks to microcontrollers, smart homes can adapt to your lifestyle and make everyday living more convenient and energy efficient. Modern vehicles are packed with microcontrollers. They manage everything from engine performance and fuel injection to safety features like anti-lock brakes and airbags. Microcontrollers also enable advanced driver assistance systems, such as lane keeping and adaptive cruise control. By processing sensor data in real time, they help make driving safer, more efficient, and more enjoyable. The automotive industry relies heavily on these chips to deliver cutting-edge features and reliability. Healthcare microcontrollers play a vital role in devices that monitor, diagnose, and treat patients. They are found in blood glucose meters, heart rate monitors, and portable ultrasound machines. Microcontrollers ensure these devices operate accurately and reliably, often in critical situations. Their small size and low power consumption make them perfect for wearable health tech, enabling continuous monitoring and rapid response to changes in a patient's condition. From remote controls to gaming consoles, microcontrollers are at the heart of many consumer electronics. They interpret user inputs, manage displays, and control sound and connectivity features. Microcontrollers make it possible for devices to respond instantly to your commands, providing a seamless user experience. Their adaptability allows manufacturers to create innovative products that are both powerful and user-friendly. Factories and industrial plants rely on microcontrollers to automate processes and ensure precision. These chips control robotic arms, conveyor belts, and quality inspection systems. By processing sensor data and executing commands in real time, microcontrollers help increase productivity, reduce errors, and maintain safety standards. Their robustness and reliability make them essential in demanding industrial environments. Microcontrollers are designed with features that make them ideal for embedded applications. They typically have low power consumption, allowing them to run on batteries for extended periods. Many offer built-in timers, analog-to-digital converters, and communication interfaces like UART, SPI, and I2C. These features enable microcontrollers to interact with a wide range of sensors and devices, making them highly versatile and adaptable to different tasks. Several microcontroller families have become industry standards. The Arduino platform, based on Atmel microcontrollers, is popular among hobbyists and educators. PIC microcontrollers from Microchip technology are widely used in industrial and automotive applications. ARM Cortex-M series chips power everything from smartwatches to home appliances. Each family offers unique features and strengths, catering to different needs and markets. Microcontrollers are programmed using languages like C, C++, and sometimes assembly. The program or firmware is loaded onto the chip using a programmer or development board. Many platforms, such as Arduino, provide user-friendly environments that make it easy to write, upload, and debug code. This accessibility has opened up microcontroller development to a wider audience, from students to professional engineers. Development boards like Arduino, Raspberry Pi Pico, and STM32 Nucleo make it easy to experiment with microcontrollers. These boards provide all the necessary connections and interfaces, allowing users to prototype and test their ideas quickly. They're widely used in education, prototyping, and even small-scale production, making microcontroller technology more accessible than ever. Microcontrollers interact with the world through sensors and actuators. Sensors provide data about the environment such as temperature, light, or motion. Actuators like motors and LEDs allow the microcontroller to affect the environment. By processing sensor data and controlling actuators, microcontrollers enable devices to respond intelligently to changing conditions. Microcontrollers use various communication protocols to exchange data with other devices. Common protocols include UART, SBI, and I2C for short-range communication, and wireless options like Bluetooth and Wi-Fi for longer distances. These protocols enable microcontrollers to connect with sensors, displays, and even the internet, expanding their capabilities and applications. Efficient power management is crucial for microcontrollers, especially in battery-powered devices. Many microcontrollers offer sleep modes and low-power features to conserve energy when not actively processing data. This allows devices like fitness trackers and remote sensors to operate for months or even years on a single battery, making microcontrollers ideal for portable and remote applications. Many applications require microcontrollers to respond instantly to events. Real-time operation means the microcontroller can process inputs and produce outputs within strict time constraints. This is essential in systems like automotive safety, industrial automation, and medical devices, where delays could lead to failure or danger. Real-time capabilities are a defining feature of many microcontroller-based systems. Microcontrollers are the heart of embedded systems, devices designed to perform dedicated functions within larger systems. Examples include digital watches, washing machines, and smart thermostats. Embedded systems are everywhere, quietly performing their tasks with reliability and efficiency thanks to the microcontrollers inside them. Internet of Things, or IoT, is a rapidly growing field powered by microcontrollers. IoT devices collect and share data over the internet, enabling smart homes, wearable tech, and industrial monitoring. Microcontrollers provide the processing power and connectivity needed for these devices to function, making them a key enabler of the connected world. Wearable devices like smartwatches and fitness trackers rely on microcontrollers for their compact size and low power consumption. These chips process sensor data, manage displays, and handle wireless communication, all while fitting into a tiny package. Wearable tech is a perfect example of how microcontrollers enable innovative, user-friendly products. Robots, from simple line followers to advanced humanoids, depend on microcontrollers for control and decision-making. Microcontrollers process sensor inputs, control motors, and execute program behaviors. Their ability to handle real-time tasks makes them ideal for robotics, enabling precise movement and intelligent responses to the environment. Microcontrollers have sparked a revolution in DIY electronics. Hobbyists use platforms like Arduino and ESP32 to build everything from home automation systems to custom gadgets. The accessibility of development boards and online resources has made it easier than ever for anyone to experiment, learn, and create with microcontrollers. Microcontrollers are a powerful tool for education. They help students learn about programming, electronics, and problem-solving through hands-on projects. Educational kits and platforms make it easy to get started, fostering creativity and technical skills in the next generation of engineers and inventors. As microcontrollers become more connected, security is increasingly important. Secure boot, encryption, and authentication features help protect devices from hacking and unauthorized access. Manufacturers are continually improving security measures to keep data and systems safe in an interconnected world. Designing with microcontrollers presents unique challenges. Engineers must balance performance, power consumption, and cost. Choosing the right microcontroller for an application involves considering factors like processing speed, memory size, and available peripherals. Overcoming these challenges is key to creating efficient and reliable products. Future of microcontrollers is exciting. Advances in semiconductor technology are making them smaller, faster, and more energy efficient. Integration with artificial intelligence and machine learning is opening up new possibilities, from smarter home devices to advanced robotics. As technology evolves, microcontrollers will continue to play a central role in innovation. Energy efficiency is a top priority in microcontroller design. Low-power modes, efficient processing, and advanced power management techniques help extend battery life and reduce environmental impact. These features are especially important in portable and remote devices where every milliwatt counts. Microcontrollers have become incredibly affordable, making advanced technology accessible to more people. Low-cost development boards and open-source software have democratized innovation, allowing students, hobbyists, and startups to bring their ideas to life without breaking the bank. One of the strengths of microcontrollers is their flexibility. Developers can customize firmware to suit specific applications, whether it's a simple timer or a complex automation system. This adaptability allows microcontrollers to be used in an endless variety of products and industries. The open source movement has had a huge impact on microcontroller development. Platforms like Arduino and ESP32 offer open hardware and software, encouraging collaboration and innovation. This community-driven approach has accelerated learning and made advanced technology available to everyone. Microcontrollers make it easy to move from prototyping to full-scale production. Development boards allow for rapid testing and iteration, while scalable manufacturing processes ensure that products can be produced efficiently and cost-effectively. This streamlined path from idea to market is a major advantage for innovators. Microcontrollers contribute to sustainability by enabling energy-efficient products and smart resource management. From smart thermostats that reduce energy waste to precision agriculture systems that optimize water use, microcontrollers are helping create a greener, more sustainable future. Advances in semiconductor technology have made microcontrollers smaller and more powerful. Miniaturization allows them to be embedded in tiny devices, from hearing aids to smart sensors. This trend is opening up new applications and making technology more discrete and integrated into our daily lives. Microcontrollers are built to last. They're designed for reliability with features like error correction and watchdog timers to ensure continuous operation. This makes them ideal for mission-critical applications where failure is not an option. Their longevity and stability are key reasons why they're trusted in so many industries. Let's look at a real-world example, the smart thermostat. Microcontrollers process temperature data, learn user preferences, and control heating and cooling systems. They connect to the internet for remote access and energy monitoring. This combination of sensing, control, and connectivity makes smart thermostats a perfect showcase for microcontroller capabilities. Fitness trackers use microcontrollers to collect and analyze data from motion and heart rate sensors. They manage displays, store activity logs, and sync with smartphones. The low power consumption of microcontrollers allows these devices to run for days on a single charge, making them convenient for everyday use. Industrial robots rely on microcontrollers for precision control and safety. Microcontrollers process sensor data, execute movement commands, and monitor system health. Their real-time capabilities ensure that robots can perform complex tasks accurately and safely, even in challenging environments. In agriculture, microcontrollers power systems that monitor soil moisture, control irrigation, and optimize crop growth. These smart farming solutions help conserve water, increase yields, and reduce environmental impact. Microcontrollers enable farmers to make data-driven decisions, improving efficiency and sustainability. Home security systems use microcontrollers to process sensor inputs, trigger alarms, and communicate with monitoring centers. They enable features like motion detection, remote access, and automated responses to security breaches. Microcontrollers make modern security systems smarter and more responsive. Smart lighting systems use microcontrollers to adjust brightness, color, and timing based on user preferences and environmental conditions. They can be controlled remotely via smartphones or voice assistants, offering convenience and energy savings. Microcontrollers enable these systems to adapt and respond intelligently to changing needs. Toy robots are a fun and educational application of microcontrollers. They process user commands, control movement, and interact with their environment using sensors. Microcontrollers make it possible for toys to be interactive, engaging, and even programmable, sparking creativity in young minds. Smart appliances like refrigerators and washing machines use microcontrollers to manage operations, monitor performance, and connect to home networks. These features enable greater efficiency, convenience, and even predictive maintenance, reducing downtime and energy use. As we look ahead, microcontrollers will continue to shape the future of technology. With ongoing advances in processing power, connectivity, and integration, they'll enable smarter, more efficient devices in every aspect of our lives. From healthcare to entertainment, industry to agriculture, microcontrollers are the tiny brains driving big changes. Their story is far from over, and the possibilities are truly limitless.